Hello, friends. Welcome to Science Talk. I am your host, Jim Masso. So, what I wish to discuss with you is an article that was published in the journal Nature, and it examines what's happening as wells run dry. So, basically, with soon communities, even whole nations, could be drawing water faster than can be replenished from precipitation. Now, if the wells start running dry, what feeds wells? Usually groundwater. Wells run dry, groundwater runs dry, rivers run dry. Within 3 decades, almost 80% of the lands that depend on groundwater will start to reach their natural irrigation limits as the wells run dry. In other words, they're being sucked dry. Take, for example, in the U.S., you have the Oglala reservoir that's basically underneath the Great Plains. That's been depleted so much that it's basically pulling up brine, which is salt water. Well, if you irrigate your crops that need fresh water with salt water, you're going to kill the crops. So we're seeing in the world increasing extremes of drought and rainfall, right? Dry areas will tend to get drier, wet areas will tend to get wetter. So we're seeing this extremes being set up, driven by, of course, the rising temperatures. Water start running out. And it's already happening. 20% of those water catchments in which farmers and cities rely on pumped groundwater, the flow of streams and rivers has fallen, and the surface flow has dwindled, changed direction, or stopped altogether. The effects can be seen already in the Midwest of the United States. I just referenced that, the Oglala. And in the Indus Valley Project between Afghanistan and Pakistan, said Inge de Graaf, who's a hydrologist at the University of Freiburg. Okay, so let's give a definition of what groundwater is. Okay, it's the billions of tons of water that can be found locked away in the soils and bedrock, can be held in vast chalk limestone aquifers, silently flowing through whatever cracks be, right? So, silently flowing through the cracks in the sediments, and it is the terrestrial planet's biggest single store of liquid water. That's more so than the Great Lakes, more so than what's in Lake Baikal. Groundwater supplies the inland streams and rivers, and the flow from tributaries is an indicator of the levels of water already in the ground. Okay, for thousands of years, communities have drawn water from the wells in the dry season, relied on the wet season, rainfall, snow melt perhaps, to replenish. That's when human populations were a hell of a lot less people than they are now. So with human overpopulation, human growth in numbers, agriculture, you need to have more land for agriculture to feed all these people. That puts pressure on the groundwater system. And that pressure is basically resulting in that we're now outstripping the water. We're taking out more than what can be replenished. So when you go back to the concept of carrying capacity, that means what? It is the number of individuals of a species that an ecosystem can support based on resources that can be replenished at sustainable levels. We're not replenishing the water, so it's not sustainable. That tells you what? Too many people drawing on the resource. And now there's concerns that as temperatures continue to increase, this problem will be exacerbated. Because think about it. If the air starts warming up, warmer air can hold more moisture. This can do what? it can draw moisture out of the ground, get more evaporation. And then you then need to find a way for that groundwater to replenish if the capillary flow is sufficient. Not always. So Dr. de Graaf and her colleagues from the Netherlands and Canada report in Nature, as I just mentioned, that they use computer simulations to establish the likely pattern of withdrawal and flow. And what their simulations indicate is not good news at all. They write, we estimate that by 2050, environmental flow limits will be reached for approximately 42% to 79% of the watershed in which there is groundwater pumping worldwide, and this will generally occur before substantial losses in groundwater storage are experienced. Basically what the saying is, it will not be replenished. The drylands, home to billions of people, will experience water stress with rising temperatures, and we know this now. This has been demonstrated scientifically. Climate scientists have been saying this for years. As demand for groundwater has increased, because of the growth in human population, as well as growth of cities, some U.S. cities are at risk of coastal flooding just because so much groundwater has been extracted that the ground itself has been lowered. Think about that. You pulled out so much water, the ground sinks. And you got the sea over here. We're finding, for example, in Miami, that we've got the sea washing down some of the streets. We're finding, brackish, brinish water getting into some of the water systems there. And so we're seeing this in a lot of coastal cities. In a hotter world, plants and animals will demand more water, but in a hotter world, the probability of extremes of drought increases. Dr. de Graaf warns, if we continue to pump as much groundwater in the coming decades as we have done so far, a critical point will be reached also for regions in southern and central Europe, such as Portugal, Spain, Italy, as well as in North African countries. Climate change may even accelerate this process as we expect less precipitation, which will further increase the extraction of groundwater and cause dry areas to dry out completely and sooner. Here's another thing that we're doing. That was a change in the planet. Too many people for a finite resource, coupled with increased temperature. People can say all they want, but you can't change the laws of chemistry and physics. So if this were to happen, we don't have enough groundwater. What do you think it's going to do to crops? You're going to have crop failures. You got hungry people. What's that going to lead to? Starvation. I just did a video segment talking about the drought effects on wheat. Well, wheat crops, the models are indicating they're going to have a massive failure, potential massive failure in yields. Now you couple this with drought and pulling out groundwater and so on, you're going to lead to worldwide crop failure, worldwide starvation. Yes, wheat relies on rainfall, but the precipitation patterns themselves are changing. So, not good news. And really, once again, the scientists are not being listened to by the politicians. So, think about that the next time you have a slice of bread. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.